Thank you very much. Again, hello. My name is Fanis Prodromou. I'm a Google developer expert for Angular, senior Angular developer at the company ASI, co-organizer of the Angular Athens meetup in Greece, and an Angular content creator. So today's talk is about how to build a Planet Poker game with Angular and Supabase. And I know that you might be thinking, what is Supabase? And exactly this is what I plan to do today. I plan to explain to you what are the features of Supabase and how to use them. And of course, we will see a demo application. Guess what? A Planet Poker game, a small one. And we will see how to start with all of these kind of things. But first and foremost, what is a Planet Poker game? Can I see your hands? Who knows what the Planet Poker game is? Nice. So for those of you who don't know, Planet Poker is a process, a ceremony in Agile Scrum, where developers sit at a round table and they have some Planet Poker cards in a Fibonacci sequence, and they estimate the complexity of a user story. So this is, in a nutshell, what is the process that we are following in real life. But how about when we work remotely? We need to have an application, right? So let's create the application. And allow me here to say that I'm not going to solve a problem that exists out there. There are plenty of online tools, free online tools, but I really like the idea of creating just for the sake of this presentation. To start, what we have to do is ng new Planet Poker game, name it however you like, and then the only thing that we need to have is just one dependency. npm install at supabase/supabase-js. This is the only dependency that we need to have for Supabase. Let's see now what is the end-to-end flow of a user who interacts with an Angular application. Well, we have the user who interacts with an Angular application, and what we need to have in this application, we need to have some data to apply the presentation logic, to apply the business logic, to have the bindings, and things like that. How can we get the data? Of course, we need to have an API. Now, from the API perspective, again, we need to have some data, because on the API side, again, we need to have some business logic, to have some data manipulation. And how can we get this kind of data? From a database. So this is the flow, let's say, of a user who interacts with an Angular application. So is it a user or multiple users? And it seems that we have multiple users. And in this case, we need to have an authentication system, authentication authorization system, to know who the user is and what the user is responsible for. And there are also some applications that they need to have a real-time communication. This is also what I'm using for the Planet Poker. But here we talk about Supabase. So let's see what can we get from Supabase. Well, we can get the authentication, we can get the API, we can get the real-time, and we can get the database. All of these kind of things just from one dependency. But what is Supabase? Supabase, for those of you who don't know, is a backend as a service. And for those of you who don't know what backend as a service is, it's a solution that allows developers to focus on the front-end development by leveraging a backend system without maintaining it. And we like whenever we don't have to maintain something, right? So this is the diagram that we have, and since we have everything from Supabase, it seems that now we can have them something like in one layer. Or to state it better, we can have them just as one dependency of that service. And that dependency can have multiple layers in their architecture, but we don't care about what is happening in Supabase. And since this is a service, we need somehow to deploy that. So how can we deploy that? How can we host that? We can host that in a cloud platform, of course. We can host that in your own cloud, and we can even run it locally on your machine. These three small bullet points are very important, and the reason is that there is no vendor lock-in. As soon as you have your infrastructure, you can do whatever you like with your infrastructure. There are plenty of features in Supabase. Today, we will talk about authentication, database, REST API, and real-time. So let's now start with the authentication that I really like. Actually, I like all of these kind of features, and perhaps I will say the same thing for every feature. So the authentication, we know that is a hot potato, right? Whenever we have to deal with authentication, we are like, oh boy, no, not this one. It's a very hard one. And in fact, in Supabase, things are easy. They have a built-in authentication system who can sign in a user using user credentials, who can sign in through OTP, who can sign in through SSO, and who can sign in through OAuth. It seems that we have plenty of options to sign in a user. So let's see a code example, just to see what is happening here. What we have in terms of pattern is that we have this kind of destructuring, we have the data, we have the error, and we can reason about the data to apply the error handling. And then here we have the Supabase. If you remember previously, we installed one dependency. This is the instance of that dependency. And then we have auth, since this is the feature that we have to deal with, and sign in with password, self-explanatory method, and we're providing the email and the password. In case that we would like to have OTP using email, again, we have sort of the same thing, Supabase auth, sign in with OTP, and we're providing the email. And the idea for this one is that we will receive an email, and at the time of clicking just the link, we are automatically redirecting, and we are signed in. If you don't like the idea of email, you have also the option to do that using SMS, and the only thing that you have to do is to provide your phone. And I don't remember exactly what are the services behind the scenes, but for sure, one of them I remember is Twilio that is handling the SMS thingy. And also, we can sign in through OAuth. And here we can see that the method is sign in with OAuth, and we're providing the provider. And in this case is GitHub. And you might be wondering, wait, can I use other providers? And it seems that we have plenty of providers to use. They already have an integration with. And that's it. And intentionally, I kept a few slides for the authentication, despite that it's a hot potato. From our side, we don't have to care about refreshing the token. We don't have to care about token expiration, nor claim validation, or signature verification. All of these kind of things, which are very important, is happening for us from Supabase. Nice. So, do you remember what we are building? What we have to build is a planning poker game. And we need to have some features. One of the features is to create a board. So just to remind you, the board is actually the table, where we have the developers sitting at a round table. So this will be our board. And then we have the board details. And actually, we might have multiple tables, and we need to select a specific table to work with. And the other one is to update the estimation. So we're going to build 3 different things. And for those 3 different things, we need more features. So let's now talk about the database of Supabase. Supabase is a vanilla Postgres database, which is the choice for transactional workloads. It has a proven language, SQL. You can query your data. It has a built-in authentication system, which I really like. They're leveraging the row-level security of PostgreSQL. And what this is that you can have specific authentication system directly to your database. So it seems here that the database is the single source of truth. And I really like the fact that we have authentication here. But this one, the real-time enabled, when I first met, I was really surprised. What this means is that perhaps you can go into the database, update just one field, and automatically your UI will be updated directly by doing just a change into the database. It's an amazing one, and we will see later on how this is actually working. And of course, they have an SQL editor where we can go there and do that everything manually. But if you're like me, perhaps you prefer to have the UI interaction. And let's see an example of how to create, for example, a table. Okay? So if you want to create a table, what you have to do is to provide just the name here. The name is users. And I would like to enable the row-level security. And then, of course, we need to create some columns, table columns. And I would like to have my ID, an integer one. And you know what? I would like to have that as primary field. And I would like to have the created at type timestamp. And I want to have a default value of now, the name text, age numeric, and I can add column, click save, and done. I have my table column already there. But wait a minute, I have my table already there, and somehow now I have to use that table from my UI. How can I do that? To bridge that gap, of course, we need to have an API. So let's now talk for the second feature, the REST API. Currently, we said that we have database, PostgreSQL, and for the API, they have the PostgREST, which is a standalone web server that converts our database table into an API automatically. And the great thing for this is that whatever constraints we might have into the database, these kind of constraints are getting reflected to the API. And again, here, what we can see is that the database is a single source of truth. You can go and pick whatever architecture you like. You have the option to go and with a two-tier architecture, which means that your application, your UI application, is getting connected directly with the auto-generated API, or you can have three-tier architecture, which means that you have your own API already, and that API is getting connected with the API. From my side, at least for the planning poker game, I went with two-tier architecture. Nice. So let's now forget everything about Supabase, and let's focus in a very simple exercise. Okay? We have just one entity, users, and for that entity, what we have to do is to create some endpoints. What kind of endpoints can we create? It's a simple one, right? We're going to have the getting verb for the users, and we know that we will get back a list of users. And then we can have, again, the get verb by providing an ID to get a specific user. The post verb to create a user into the database, the put verb to update a specific user, the delete verb to delete a specific user, and the patch verb to partially update a user. OK, so this is what is happening in terms of the REST principle. Now, from Supabase, we have, like what was said previously, we have auto-generated API. This means that if we have the table users, we will have the users endpoint. If we have the table products, we will have the products endpoint. And if we have the contract table, you know the drill, we will have the contracts endpoint. Nice. So what I would like now to do into this slide is to split that into two parts. On the left part, we will see what we have from REST principle, and on the right side, we will see what we have from Supabase. Okay? So again, for the same entity, we have the entity users, and if I want to get a list of users, I'm going to use the get verb. Nice. And what do I have from Supabase? The exact same thing. Nice. OK. So if I want to get a specific user, what we are doing is that we're providing the ID. And what do I get from Supabase is this one with a query parameter. We will see what this query parameter is all about. And the same thing goes for post. We have the exact same thing. And the same thing goes with delete, where, again, we have a query parameter. But what is this query parameter? Well, the user underscore ID is the column name, the EQ is the operator, equals, and the one is the value. So what we're saying here is that I would like to get a user where the user ID equals to 1. And just for the sake of standard, this is according to REST principle. This is perfectly fine. But what I would like to point here is that, do you already see how powerful this is? Let me give you an example. Let's assume that we would like to build a contracting system. Okay? A contracting system where we know that the contracts, they have multiple fields, lots of data. Don't try to read this kind of thing. It's auto-generated using Gemini. What I would like to point here is that we have a very big payload. Think that this is 5 times bigger. Okay? And we have now to generate some endpoints for this one. And we will have all of these kind of things. We will have the get verb to get a list of contracts, get verb for specific contract, post to create, delete, and the rest of the verbs and endpoints. Nice. But we know here that if we are going to get a list of contracts, especially when we have lots of data, the performance won't be that great. Even for one contract, we know that the performance won't be that great. But this is OK. It's fine, because it's a contracting system, and we know what we have to deal with. But now we have this in this imaginary application, we have an imaginary product owner, product manager, and he wants to have another feature, and he demands the performance to be faster. And after a thorough analysis, we realized that, you know what, we don't need to have the payment details, compliance, and reviews, which are some joint tables. And we know that if we remove them, we will save some time from SQL computation, we will save some time for transferring all of the data and things like that. And nice. But how can we do that? We don't have to kill the previous one. We don't have to kill the endpoints that we currently have, and somehow have to deliver that feature. What we have to do is to go to the API developer and ask for a sub-resource, which is, again, perfectly fine from the REST perspective. And the name could be Slim or whatever, you name it. And the idea for this one is that whenever we are using that, we know that we will have a smaller payload. Nice, and things work just fine. And then, again, the same product owner has the imaginary product owner for the imaginary application requires to have a feature that should be work like that, very fast. And the only thing that we need to have is 4 properties. We need to have the contract type, the start date, end date, and the contractor name. So let me ask you, will you go to the API developer and request for another sub-resource? Slim 2, Slim new, Slim whatever? Well, no. We know that we don't do that. We will compromise with a Slim, and we'll have to convince the product manager, you know what, the performance will be, but we'll have to move on. And now let's see what we have from Supabase, the tailor-made query. Actually, in Supabase, what we have to do is to have this kind of properties into the URL. It's a bit hard to read, but from our side, from the developer perspective, what we have to do is to have a query like that. So we have, let me see, we have Supabase, which is the instance. From, we have to define which table we would like to query. And then we are selecting the contract type, start date, end date, and contractor name. And how about now if we want to have some pagination? Again, the only thing that we have to do is to have some more query parameters, or to state it better, we need to have one more chained function. And this is the range, where I would like to range my results from 10 to 15. And how about if I have some sorting? How can I deal with that? Again, same thing. One more query parameter, or else just one more chain function, where I would like to order by start date and the setting to be false. Nice. And I think here you might have a question already, and the question could be, are we querying the data from the UI? Where actually what we're doing is that we are initiating the query from the UI. A follow-up question could be, is this secure? So let me tell you what is happening behind the scenes. There is an HTTP interceptor that we do not have to develop. And on every request initiation, what is happening is that it provides into the headers the API key, which is just the API key that lives into the environment.ts file. And then we have the authorization, which is a JSON Web Token, the authorization of the user token. And all of this kind of information goes directly to the API. And if we now take this JSON Web Token and see the details that it has here, it has plenty of properties, but we can focus into this one, which is a UUID, and actually is a user ID. And we also have the role, which says that, you know what, that user is authenticated. Nice. And now let's talk a bit about the role-level security. If you remember previously, we said that in Supabase, they are using PostgreSQL, and in PostgreSQL, they have built-in authentication system by leveraging the role-level security. And the role-level security is a feature that allows you to implement authorization rules directly in your database, which means that you can control what every user can do. So for example, here we have the very first user. Let's say that the color is light blue or purple, or whatever. Let's say, for the sake of the presentation, this is a light blue user, and is the owner of the first row. And then we'll have the second user, the green user, owner of the second row, and we'll have the blue user, who is owner of the third row. And now, what is happening is that the first user, the light blue user, tries to delete the third row, and this operation will fail because we have enabled a row-level security, and this action is not allowed. And the good thing is that this action, this this response won't happen directly from the database. The response will happen directly from the API, because whatever constraints you have into the database are getting reflected to the API. And even if we have an anonymous user trying to access our data, again, this action will be rejected. I know that you would like to see some code, so let's see some code to see the things that we try to implement. If you remember, we have 3 different things: to create the board, to get board details, and to update the estimation. So let's see what is the method that I created in VS Code. So it's the method create board, and providing the board name and the user ID. What I would like to highlight here is that we have IntelliSense. So as you can see, I have here board members, boards, and profiles. These are the database tables that I created into their cloud system. And despite that, we have an IntelliSense, which is very good and convenient, and we have also error messages in case we have something wrong. And the other thing that I would like to highlight is that we have the method insert, because we are inserting something to their database. And as soon as we invoke that, we have a new entry. So this is how to create a board. Now, let's see an interesting one. And in this case, I would like to get board by ID. The very first thing that we have to do is to define the table that we would like to interact with. And here we have boards. And then from boards, what I would like to select are specific columns. I don't want to select everything, okay? Specific columns. I want to have the ID name created at, created by, and is completed. And what is happening, into that table, there is a many-to-one relationship with board members. And I can also select this kind of properties explicitly. And I would like to have the ID created at, value, board ID, and user ID. And into that table, there is another many-to-one relationship with profiles, where the only thing that I would like to get is the username. Just this. What I would like to highlight here is that you have the option to go crazy if you like and construct your query however you like. But if you don't like this idea, of course, you can just have the wild character, asterisk, and select everything. But you have the option to manually do whatever you like. This is how to get the board details, and the response, of course, will be just a JSON. And then the third one is to estimate. What I would like to do here is to update the estimation. And what we're doing is that, again, into the from, we have the board members. This is the table that I would like to interact with. And then we have to update something. And I'm providing the value. But I don't want to update everything. That's why we have to provide also some filters. I want to update only the column that, the row that the ID equals to sprint value ID. This could be board value ID. I have to change that. And now let's see how to use the real time. And this will be the last one, the last feature that I would like to present to you. So for the real time, at the time that we are creating a table, if you remember, what we had is the row level security, and down here we also have the enable real time. You can do that either during the creation of the table or, of course, later on while editing the table. And how can we use that now? We have somehow to use this one, to use this WebSocket. And actually what we have to do is to subscribe into the Postgres changes. This is how the stream is named, Postgres changes. And actually what we're doing is that we're subscribing to the database changes. But wait a minute, do we have to listen on every change? No, we can narrow it down. And I would like to listen on a specific event, insert, update, or delete, or I can listen on every event. And I would like to have my listener only for the users table. And I can even narrow it down. And I would like to apply some filtering. I would like a specific column to have a specific value. And as soon as these filters are met, then I have my callback function where I can do whatever I like. So let me show you a very quick example of how this actually works. Entire screen, start mirroring. All right, OK. And I want this guy to be left half, and I want this guy to be right half, and this one to be, again, left half. Oops, wrong key binding. Awesome, nice. So what we have here is two users. On the left side, we have the user Fanis, and on the right side, we have the user Tanya. Here we have just the menu where we have the dashboard, create board, boards, and logout, and the same thing, of course, happening into the right side. Different browsers, Chrome and Firefox. If I go now into the list of boards, we can see that we do not have any boards. And the same thing is happening here on the user Tanya. So we do not have any boards. So let's now try to create a board. Okay, so let me go here to dashboard, and here I will click create board. And I would like the board to name that, let's say sprint 1, and I will create that. And we have just entered the board. And what we can see here is that it's only me under this kind of board, and I have the cards in Fibonacci sequence, 1, 2, 3, 5, and so on. And somehow we have to invite the other user entering the same board. So how can we do that? So here I have just a small arrow, a small icon, where if I click this one, actually I'm going to copy and paste a magic link. And if I paste that to the other user, we expect that user automatically to enter the board. And as you can see, I'm not refreshing the page. I'm just having some WebSocket listeners that I'm listening to this kind of thing. So what we can see, do I have to zoom in a bit? OK, I think it's OK. What we can see is that we have some sleeping faces here and sleeping faces here. Nice. The left side, that user thinks that the complexity of this user story is 3. And we're doing that, and we can see that we have 3 here, and we have the smiling face here, which means that it voted, but we cannot see that yet. The other user thinks that the complexity is 5, and we can see the same thing, the 5 and smiling face on the other user. And now it's time to reveal the cards. As soon as everyone voted, we can reveal the cards and see what is happening. And as we can see that we have now for user Tanya 5 and for user Fanis 3. Awesome. So this is what is happening. And if you noticed that I didn't refresh my page, like I said, everything is happening behind the scenes using WebSockets. So let's see now what this is all about. This is supabase.com, as you can see into the URL here. And this is their system, and this is where I created my infrastructure. And I have the tables board members, boards, and profiles, the things that we saw previously in the IntelliSense. And what we can see now into the board members is that I have 2 different rows. So let me have that on the left half again. And let me ask you, what will happen if I now change this value from 5 to 8? I didn't click yet enter. At the time that we're doing that, we expect the user on the right side to be updated. And this is what we're saying, that they have real-time enabled. I change something directly to the database, and the UI is getting updated automatically. And of course, the other user updated as well. So let me go to the extended display. And like I said, that would be the last one. And just to wrap up, in summary, what we saw today is about the authentication and how to use that, the methods of authentication, the database, how to create tables, and how to use this kind of tables utilizing the API, the auto-generated API, and how to have also the real-time communication in your application. So thank you very much for your time and your attention.